Hi, let's multiply and divide some rational expressions. All right, we're going to look at this first one where we're multiplying, and just like with simplifying, we have to factor everything first. We can't leave anything unfactored. So I'm going to go ahead and look at this first numerator, 8x minus 80. I can factor out an 8. There's an 8 that both of those terms have in common. What I have left is x minus 10. And then I am looking at the denominator for that fraction. It's just an 8. That can't be factored, so I'll just put 8. Now I'm going to look at the second fraction, times, in this numerator in the second fraction, 2x plus 18. I can factor out a 2. Both those terms have a 2 in common. So I'm going to factor out a 2, and I have x plus 9 left. And then in this denominator, that's a quadratic. There's no GCF that I can factor out of it first, so I'm going to do this and put a times c, so negative 90 on the top, negative 1 on the bottom, and I'm trying to think of two numbers that multiply to get negative 90 and add to get negative 1. So negative 10 and 9, those multiply to get negative 90, and when I add them together I get negative 1. Because it's just a 1x squared, I really don't need to do that whole box area model thing. I can jump straight to my factors. So x minus 10, x plus 9. Okay, so now everything is factored, and just like with simplifying, as long as it's a multiplication in between these two fractions, I can just look for common factors in the numerator and denominator. So I'm seeing 8, and there's an 8 in the denominator. 8 divided by 8 is just 1. I'm seeing an x minus 10 and another x minus 10 in the denominator. X minus 10 divided by x minus 10 or over x minus 10 is just 1. And x plus 9 and another x plus 9 in the denominator. Those are exactly the same. They cancel out. All I'm left with is the 2. 2, and there's nothing left in the denominator, so it'd be 2 over 1, which is just 2. All right, let's try a dividing one. So same thing though, I have to factor everything first. I'm going to put, because this is not a fraction, I'm going to put it over 1. And then also we're going to end up changing this division to multiplying by the reciprocal. So when you're dividing by a fraction, you can multiply and then just change it to multiplication and then flip over, do the reciprocal of whatever you're dividing by. All right, so we're going to start with factoring. I'm looking at this, and I'm looking for a GCF that I could factor out first. There's nothing that goes into all of those terms, so then I'm going to jump to this method. A times c on the top, so 7 times negative 12, that's negative 84. And then you put b on the bottom, 17. So now I'm trying to think of two numbers that multiply to get negative 84 and add to get 17. I just did 7 times 12, but there's no way to combine those to get 17. So I'm just kind of go through a list of different things that multiply together to get 84. 14 times 6, there's no way to combine those so to get 17. How about 4 times 21 is 84. Oh, and there's a way to combine those to get 17 if I do positive 21 times negative 4. So now those multiplied, 21 times negative 4 is negative 84, and 21 plus negative 4 is positive 17. Because it's a 7r squared, it's not just a 1r squared, then I need to do the area model. I'm just going to erase these numbers so that I have more room to write. Okay, so we put the first term, 7r squared, in the first box, and then I'm going to put the negative 12 in the last box. And then I use these numbers, 21 and negative 4, to fill in what goes in these other boxes. So 21r and negative 4r. It doesn't matter which one. You can switch those. You'll still get the same answer. So now I'm looking at the rows and columns and factoring out a GCF from each row and column. So for example, if I look at this first column, there's nothing in common with 7 and 4 that I can factor out, but I can factor out an r. And then if I look at the next column, I can factor out, I'm thinking of what goes into 21 and 12, it would be 3. And then if I look at the top row, so I'm looking at 7r squared and 21r, I could factor out a 7r. And then the bottom row, I could factor out a -4 is what they have in common. And it's good to just kind of pause and take a second to make sure that when you multiply r plus 3 times 7r minus 4, that it does in fact equal everything inside the boxes. Okay, so we factored that numerator is over 1, and I'm going to change this to multiplying instead of dividing, and I'm going to do the reciprocal. We're going to flip this other fraction over. So what I was saying earlier was when you're dividing by a fraction, you're going to change that to multiplying by the reciprocal. So change the sign to multiplication, and then flip over the second fraction. As I'm flipping it over, I am also going to factor. So this denominator is now going to be in the numerator, but I'm also going to factor out a 2. And then the 14r minus 8 is going to go in the it's in the numerator, it's going to go in the denominator, the bottom, it's going to flip over, and then I'm also going to think of what I can factor out of 14r and 8, and that would be 2. If I factor out a 2 from 14r, I have 7r, and I factor out a 2 from the minus 8, now it's minus 4. Okay, once everything is factored, and as long as there's a multiplication in between these two fractions, now I can go through and look for anything that's the same factor in the numerator and denominator. There's an r plus 3 in the numerator, but I'm not seeing any r plus 3's in the denominator, so that's not going to cancel out with anything. There's a 7r minus 4 and another 7r minus 4 in the denominator, so those will cancel. I'm seeing a 2 divided by 2. And then r minus 1, there's no other factors in the denominator, so that can't cancel out with anything. So I'm going to write what I have left. R plus 3 times, because there's a multiplication between these two fractions, times r minus 1. You do not have to distribute that back out, and there's just a 1 left in the denominator, so you don't have to put over 1. You could just leave it like this. But you don't have to distribute that. You can just leave it as factors, r plus 3 times r minus 1.